transformer. Transformer is a static device which transfer electrical power from one electric circuit to another electric circuit at same frequency but maybe at different voltage levels. Let us consider here we have two coils. Coil which is connected to the supply may be termed as, or input side is known as primary, and coil which is connected to the load or output side is known as secondary. These coils are not connected electrically but are connected magnetically, and generally your transformer works on the principle of electromagnetic induction. What is electromagnetic induction? Whenever magnetic flux linking a coil changes, EMF would be induced. And whether this flux is changing with this coil, EMF will induce in this coil. Flux will change in this coil, EMF will induce in this coil. And the EMF induced in this coil mutually induced EMF. Whenever we apply an alternating voltage to primary side, an alternating magnetic flux would be established which links both the windings, primary winding as well as secondary winding. As magnetic flux is linking with the primary winding, EMF will induce in the primary winding which is known as self-induced EMF, and as same flux is also linking with secondary winding, EMF will induce in the secondary winding, and that EMF induced is known as mutually induced EMF. And your EMF induced is directly proportional to N d phi by dt, or minus N d phi by, where N be the number of turns. Means if number of turns are primary is N1 and number of turns in the secondary is N2, therefore E1 by E2 is N1 by N2, or E2 by E1 is N2 by N1. Means the EMF induced is directly proportional to the number of turns. By increasing or reducing the number of turns, we can change the voltage level. That's why this transformer is being used in different electrical applications. Where we require a low voltage, for example, we have to operate the circuit on 12 volt, you will find small transformers. So we can generally step downs. That is being used in the electronic appliances. Whereas in case of power, where we require, for example, at our substation, generating station, voltage is between 11 to 33 kV. Then we step up it up to 400 kV, 232 kV, 765 kV, which is the transmission level of the voltage. Then again we step down at the substation, again we step down into the distribution station. So here we step up, so we will require a step up transformer. Here we will requires step down transformer, further step down transformer, and then supply is distributed to the load. First, in this we will discuss construction of the transformer. That means the windings are not connected electrically, they are connected magnetically. Certain magnetic material would be required for the magnetic flux by which these two windings may be connected magnetically. Construction of the transformer. The transformer construction, the first main part is the transformer core. That is the magnetic material. The core of the transformer is important one. On the basis of its core construction, it is divided into other two types. We will discuss it. The core is generally made up of magnetic material and having a lower hysteresis loss. So generally, silicon steel is being used as a core material. And in addition to this silicon steel, we will use silicon steel laminations. And thickness of these laminations are up to 0.5 mm. Laminations are being used to reduce up the eddy current lossage, and magnetic material with having a lower hysteresis loop area is used for minimum hysteresis lossage. So here silicon steel lossage, or to increase its permeability, the heat treatment is made, and that CRGO silicon steel, called rolled grained oriented silicon steel, so that the hysteresis lossage can be minimized in the metal. So generally we use laminations, and these laminations are being used in such a way that the gap between the laminations should be minimums. They are staggered in, for example, we are using these L-shaped laminations. So they will be placed alternatively, so that the air gap between these laminations should be minimum, and these laminations are being insulated by certain varnish or oxide layer, and they are being placed alternatively one above the other, so that the air gap would be minimum, and they are staggered in such a way, or they are butted together to form a core shape. So generally, on the basis of the construction, whether it is a single phase transformer or three phase transformer, on the basis of the construction of the core, your transformer is of two types. One is core type, another is shell type. In single phase transformer, generally in core type transformer, we have L-shaped laminations which form a rectangular shape. And this will form this shape. They would be placed alternately and will form a solid shape with minimum air gap at the joints and windings would be placed on each limb. On one limb we can place low voltage winding, other limb we can place a high voltage winding. Let this be the low voltage winding, this will be the high voltage winding. Or a portion of low voltage winding is placed on one limb and a portion of high voltage winding is placed on the other limb. Low voltage winding, high voltage winding. Or the coils may be sandwiched. So this configuration of the coils, it may have different configurations. These may have helical type, spiral coils, crossover, continuous disc winding. So as per our requirement or as per the designing of the transformer, a particular coil may be used. Means in core type transformer, most of the core portion of the core is surrounded by winding. And in shell type transformer, another transformer is shell type transformer. This configuration is generally being used in single phase application. It has E and I shaped laminations. And they are placed alternatively or staggered in such a way that the air gap would be minimum and it will form a compact shape. And this will have this particular shape. When these E and I type strip are being placed. Here, low voltage winding is being placed nearer to the core and high voltage winding is placed away from the core. So this is your low voltage winding and this is high voltage. Generally, high voltage winding is placed away from the core because if it is placed nearer to the core due to large heat dissipation, the insulation arrangement between core and winding should be more. Whereas if it is placed away from the core, means outer sides, the air or oil will cool down this particular coil. That's why your high voltage winding is being always placed on the outer side. Will be discussed in the construction of the transformer, primary winding as well as, in the working principle, primary winding, secondary winding. But in electrical engineering, we term these winding in terms of their low voltage, high voltage. The side which is connected with the source would be termed as low voltage winding, and side which is being connected with the output or to the load is known as secondary winding. any winding may be primary or secondary. So these windings are separated by certain insulating materials. That would be paper, mica, whatever insulating material being used between core and windings. Generally, in single phase configurations, shell type transformers are used. In shell type transformer, this may be the configuration. Low voltage winding, portion of in half low voltage winding is being connected, in half portion high voltage winding is being connected. So any type configuration may be there. It means it has 3 limbs, but winding is placed on the one limb. So here most of the coil portion is surrounded by core. So we can say in core type transformer, windings surrounds the core, whereas in case of shell type transformer, your winding, most of the part of the winding is surrounded by core. For example, if we requires 3-phase core type transformer, so this, in case of 3-phase core type transformer, this shell type, single phase shell type transformer becomes core type transformer of a 3-phase system. On each limb, we have placed both the windings, low voltage winding and high voltage winding. Low voltage, high voltage. Low voltage, high voltage. Low voltage, high voltage. So this will becomes core type transformer. Likewise, here your winding surrounds the core. So single phase shell type configuration becomes same configuration or same shape of the core becomes core type transformer in case of 3-phase winding. Because in 3-phase transformer, 3 windings are to be placed. 1 winding for each phase. Low voltage, high voltage winding, low voltage, high voltage winding for another phase, low voltage, high voltage winding for the another phase. Shell type transformer, you will get the extra layer. Means configuration would be such that here your core surrounds the windings. It requires the additional core, additional size. That's why in power transformer, in 3-phase transformers, most of the places you will find the core type. In our all power applications, we use the core type transformer. There is no difference between single phase, 3-phase. Only difference is configuration will becomes for the 3-phase in case of 3-phase transformer, and in case of single phase it will be configuration will be for the single phase. So this is the now windings. Second part is winding. We have low voltage winding as well as high voltage winding, generally made up of copper or aluminum windings are being used. And these windings are varnished or by certain insulating material. For higher power applications, we use the paper insulation on the windings, and these windings are separated each other by another certain insulating material, that would be paper, cardboard, or some other insulating material being placed between core and windings and between windings. These windings, in case of single phase, we have two coils, one is for the low voltage side, another is for the high voltage side. And in case of three phase winding, it would have three coils, and these coil connections may be connection in case of three phase may be in different. It may be connected in star or delta. Either star, you are well aware about that, star connection, and in case of delta, particular side is being connected in delta. Generally, you see the distribution transformer available at your supplying to your residential building or your house is generally delta star connected, where input side is delta connected, output side is star connected. It is generally 11/0.4 kV transformer. Means input side is 11 kilovolt and your output side is 400 volt. This 400 volt is the line to line voltage, and phase voltage for single phase application between phase and neutral you will get the 230 volt. So in case of three phase connections, they are not connected directly in terms of star delta delta. They are connected in star delta, but these star delta or star star connections may have certain phase displacement. So according to their phase displacement, they are broadly classified into four groups. First group is zero phase sequence, phase difference. That is term named as YY0 or DD 0. Means both the windings, primary winding is star connected, secondary winding is star connected, and phase displacement between both the windings would be 0. They will be connected in such a way that the phase displacement would be 0. Likewise, delta delta, primary is connected in delta, or you can say low voltage winding is, if low voltage winding is primary, it is connected in delta, high voltage is connected in delta with having 0 phase displacement. -180 degree phase displacement. Means y by 6 or d6. So these primary and secondary windings, 6 means the phase displacement is 180 degree. -30 degree lag phase displacement. Means your secondary side would lag by phase angle of 30 degree. Means that's EMF of the secondary side would lag the EMF of the primary side by a phase angle of 30 degree, and that would be denoted by y by 11 or y by 1 or yd1 or dy 1. So generally we use each star delta or delta star with a phase displacement of 30 degree. Likewise, 30 degree lead. Likewise, denoted by YD11 or DY11. This 11 indicates that your secondary side, delta side, is leading the star. The phase displacement between their phase voltages would be 30 degree leading. Means secondary side is leading by an angle of 30 degree. Next part is container of the transformer. That is named as tank of the transformer. That may be container or named as transformer tank. Generally made up of fabricated steel, which contains or which houses the winding and core of the transformer. In this, for example, this transformer is being core and windings are being placed. For example, let it be 3-phase or single phase. If it would be 3-phase winding would be placed. If it is a single phase winding would be placed. The strength should be such that it would be able to protect this container, or this container would be able to sustain in normal as well as somewhat abnormal conditions during the operation, or as its strength should be enough, it can be easily lifted up or lifted down for replacement or placement purposes. Another part is transformer oil. This is basically mineral oil or hydroxyl oil which is refined from crude oil, and this oil must have high dielectric strength, and this oil is being filled up in this transformer tank. It must have high dielectric strength, low viscosity to provide heat transfer, good resistance for emulsion, and high flash point. And basically this transformer, this oil is being used for insulation purposes as well as for the cooling purposes. and this transformer oil is filled up with the oil. Fifth part is cooling tubes and radiators. Cooling tubes or radiator. In your transformer, power transformer, you will see generally there are the tubes around the tank. And purpose of these tubes to increase the oil circulation area of the transformer or to increase the oil and air contact area so that your oil would be continuously cooled down or circulate in the tubes. We may have, for further higher rating, in place of cooling tubes, we have radiators. This shape. You will find the fins and purpose is to increase the circulating area of the oil as well as contact area of the effective contact area of the oil would be increased so that the transformer oil can be cooled down continuously. To increase the further more cooling down or heat is extracted fastly, you can place fans on this. Fans are being placed on the radiators so that it will provide the better heat extension or heat would be extracted for better range. Next part is bushings. Generally made up of porcelain, oil type, which is used to make the contact between your winding and to the external circuit and provide as an insulator as well as the protector or supporter for this winding connections. So generally used for the winding connections and makes connection with the external circuit to the winding of the transformer, for example. Likewise, we would have the connection with the high voltage side also, another side. Low voltage side also. If we have shown the connections for high voltage, similar connections would be for the low voltage side. Conservator. Conservator is basically an additional tank being placed above your transformer, and this is basically generally half filled with oil, because when your transformer is heated up, your gases expands, your oil expands, and it will try to come out, and it will come out to the heated or expanded oil would be filled up in the conservator. When your transformer cools down, your oil will comes to the transformer tank back. So that to maintain the requirement of the oil, this conservator is being used. During the heat up of the transformer, your oil expands, and during cooling down of the transformer, it supplies to the oil to the transformer. Breather. Breather is generally being used to absorb moisture from the air, and being generally, for example, it is a vent pipe. It is being connected with this vent pipe. Silicone gel. Crystals are being used which are impregnated with cobalt chloride, and generally color of this silicone gel is blue. Whenever your oil expands, air would comes outside. When it cools down, it will take the air from the atmosphere, which may have the moisture content. To absorb this moisture contact, the silicone gel is being used. And initially it would be blue, and when it will be damped out or utilized, it would becomes whitish pink. Patanjali. This is basically a gas actuated relay, and being placed in between transformer tank and conservator. Whenever your certain fault is being developed in the transformer heat ups the fastly. A lot of heat will develop, and this heat will be expand the oil fastly towards the conservator tank. So when this movement will be there, this Buckles relay would operate and give signals or give the alarm signal, or it will actuate the signal or give the signal to the protective device, so that this transformer can be disconnected from the supply. Insulation. Insulation is being important part that is being wound on the coil. Generally paper insulations or varnish is being used to insulate your winding. Insulation is being provided between your tank and core, between your winding and core, between winding and windings, and that is purpose to provide the better dielectric strength. So in the construction of the transformer, we have discussed different parts: conservator, your oil, transformer oil, breather. We have used the Buckles relay. So generally these parts are being used where we use the medium of transformer is oil. Where for high rating transformer we use oil type transformer. For low rating transformer we use air cooled transformer. You will find certain transformer there is no transformer tank. This is just is being open, and generally this transformer is being cooled down by air. You can see these transformers in your inverters. With air, these transformers are air cooled. So all these other parts will be removed in that transformer. Whereas where the transformer is being used, power application rating of the transformer is high, then certain arrangement is to be required, and all these parts, whether it is a conservator, whether it is a breather, whether it is a buckle relay, these parts would be included in the